Our second presenter today is Amy Chiang from the University of Michigan.
Thank you. Hello, my name is Amy. I'm from the University of Michigan. I'm doing a master's there. I'm part of the School of Natural Resources and Environment, and my presentation today is on the Lake Michigan offshore wind turbines. I did a distance-to-shore analysis. This is my overview. So some background, I'm looking into offshore wind turbines because I'm interested in renewable energy. So I think renewable energy is going to be the next step for replacing fossil fuels. So does anyone know how many more years of natural gas we have left in the United States? Okay. So we have 92 years left just for the United States. While that may not be relevant to us for our lifetime, most likely, that's still important because it's going to contribute to greenhouse gas emissions and pollution emissions. Also, natural gas is what wind energy is most likely going to replace in comparison to the rest of the energy mixture. Also, in terms of offshore wind energy, does anyone know how many offshore wind turbines we have in the United States? Okay. So we don't really have any. We have one off the coast of Maine. It's put out there by the University of Maine. It's actually 1/8 of the size of a real wind turbine. They're just putting a test turbine out there to see how it does and takes studies or collect data with it. But Europe has a lot more wind energy going on. So this conclusion for me is that there's definitely a huge market for offshore wind energy, and this is why I'm doing a study to see offshore wind turbine siting in Michigan. So for the state of Michigan, I'm looking at Lake Michigan. I find it is ideal because even though Lake Erie is shallower, there is more governance for Michigan on the Lake Michigan side. I think Ohio has most of Lake Erie to develop. And depth is important because you rather develop offshore wind turbines in shallower areas because you don't have to invest as much in the foundation, so it costs less. So yes, there has already been work on siting offshore wind turbines in Lake Michigan, but I'll tell you in a second why my work will be different. And yes, there has also been an offshore wind turbine project that has been attempted in Lake Michigan, but I'll talk more about that in a second. So the siting example, or a siting map that has already been done, was done by the Michigan Great Lakes Wind Council. They've taken into account shipping lanes, military areas, ecological areas, a lot of criteria, wind data, so they look at wind speeds, they looked at lake depth, like bathymetry, like I mentioned before. So these are the results that they've had so far. And these results were done in 2009, 2010. So the Scandia, their project does take into account some of the results from that siting. And they picked this area, Muskin-Ottawa County, outside Muskin-Ottawa County, to develop a 500 megawatt wind farm. But they were not able to complete it because there are too many people who live in that area that were opposed to the wind turbines. They didn't like the way it looked. So what they call it is viewshed, which is just saying that they live in this area and they don't like the way, they think it's visual pollution, basically, of wind farms. So this conclusion from both the siting example and this project that was attempted tells me that viewshed needs to be taken into account for a wind farm siting experience, wind farm siting, so that a project that can be developed and already invested in, because the Scandia already spent money to try to put a project out there, will be more successful. So my research question is, what is the impact of viewshed, environmental quality, and the electricity sector on offshore wind farm siting in Lake Michigan. So that's looking at the social aspect of viewshed, the environmental aspect of like pollution abatement and ecological factors, and also the cost is also integrated into the electricity sector to see like I mentioned, natural gas, see what kind of other energies it will be offsetting. So in a nutshell, I'm taking the data I have, I'm putting it into GIS, I'm going to develop this viewshed, environmental, quality, and electricity sector layers, like GIS layers, and then, so that's what's part of adding it together and getting an ideal siting location in Lake Michigan to place offshore wind turbines that will be successful, as opposed to the previous one. And my focus in this project is on the electricity sector because this is my sub-question, I'm doing the least cost path distance, which is the path from the turbine location to the shoreline that takes into account the bathymetry to represent transmission lines. And that transmission line distance will show the cost. Essentially, it'll be a function of the cost of what the transmission will be. So my methodology, my data sources were from the Michigan Geographic Data Library, which I'm sure many people who do projects on Michigan use their resources. And I've also grabbed population data from Social Explorer. And the variables in my analysis were on the distance to shore, bathymetry, which is lake depth, and population. So first, I'm going to list out some of the steps I did. I picked out like 500 points in Lake Michigan to analyze. I determined the foundation type because foundation type is going to be another cost function, and that was an easy thing to analyze. I calculated the least cost distance from these 500 points to the shoreline. So this is a cartographic map of just the least cost distance. Then I extract the values from the least cost distance back into the 500 points I've chosen. And then I added in the population data just for background information to map out my future work that I'll be doing. And I calculated, to do a comparison, I calculated the shortest distance to shoreline from these points that don't take into bathymetry. Okay, so my results, this is what I attached to my paper, but it doesn't look very good, so I broke it out. My foundations, I determined that the foundations for the turbines, most of the lake's pretty deep, so most of the foundations I found were to be the floating type of foundation. This is my least cost distance results. So on the right, or on the left, is the actual least cost distance. On the right shows the near cost. I zoomed into my results here, so here you can kind of see how from each point, I didn't show the contour lines, but each point, it doesn't follow a straight line to the shoreline because the bathymetry does add into effect how far it has to travel, while this shortest cost distance is just a straight line to the shoreline. Also, you can see the comparison for some of these points, like here or here. The points here would actually take a different path. So there's two parts of this result, is that one, from the points, the least cost distance would travel a different path compared to a near cost distance. And the second is that it would land at a different location on the shoreline compared to the near cost distance. Okay, so I picked one point just because I was kind of curious to see how much difference it was from taking bathymetry into account versus not taking the bathymetry into account. And between the cost path and just doing the shortest distance, there was a 2,000 meter difference in the distance. So this may seem like a lot, but considering that this point is already pretty far out from the shoreline, it's not very far, like the difference between the two distances aren't that large. I'll talk more about that in a little bit. So finally my results show that while I did pick out many points that were all along Lake Michigan, ideally the points I do want to observe more are the ones close to the shoreline. The viewshed data that I do have are within 16 kilometers of the shoreline, so I don't really need to analyze the entire lake. I would want to analyze more points close to the shoreline to show more of the differences between points, because each of the points are 10 kilometers apart from each other. And the cost path distance is not that much further than the shortest path distance, so yes, like I said, I want these points, I want to analyze points that are close together. So for my future work, I'm actually more curious about whether avoiding the depth might be more cost effective than actually just finding the shortest distance from the point to the shoreline. So in the analysis I did, I'm assuming that the transmission lines follow the contour depth from the point to the shoreline, and it just takes the shortest cost path, even though it might hit deeper areas. But the actual cost of this might be different from just avoiding deeper areas, taking a longer route from the point to the shoreline, and not following a least cost path. Also, in my future work, I want to add more details to the points I gridded, add more points, and do more analysis on the points close to the shoreline, as opposed to just doing points all along the lake. And I would complete this mapping analysis to include the viewshed effects, the environmental effects, and other electrical sector effects that I talked about earlier, and possibly compare my sighting results with the sighting results that were already done by the Great Lakes, Michigan Great Lakes Wind Council. I would like to acknowledge the National Science Foundation. I'm under a grant to do research for the University of Michigan. My advisors, Dr. Greg Keeling, Dr. Jared Kelly, a PhD student who did this research before me, Dr. Liang Tsai, and my GIS professor, Dr. Paul Delamater, and Center of Sustainable Systems. Does anyone have any questions?
Hi, very interesting.
Hello.
It occurs to me though, I mean, just getting the shortest path or the least cost path to shore really is only part of the problem. I mean, you got to link this transmission in with the existing transmission grid.
Yes.
Which means you have to come onto shore and eventually hit a substation.
Yes.
Which means you're going to either, one, link up with an urban area where there's a substation, or in a rural area where there's an existing power station.
Mm-hmm.
Did you take any of those things into consideration when looking at this, or have you thought about that?
I have thought about that. So an assumption I'm making in my study is that the cost of traveling the distance underwater with the transmission cables are going to be significantly greater than having to move from a point on the shoreline that may be urban or more rural to a more populated area that has a substation. So,
but it'll be more politically costly to travel over land.
So is viewshed is politically costly, but yeah.
If this project at some point becomes reality, it would become the first windmill park in freshwater.
Yeah.
And as you know, right now, half of Lake Michigan is frozen over.
Yes.
What is going to be the impact of the energy of moving ice on the physical structures as a side challenge to all of this?
That's a good question. I'm not quite sure because I haven't done work on looking at the ice effects, because there are ice effects. I do know that for onshore turbines, they already have problems with that. For turbines that are built further up north that already have a lot of snow, and there's this thing called ice throw where the turbine spins and the moisture collects on the turbine and then it throws it out to, I don't know, houses or cars or something. But I'm not sure what the moving water effects are. I know that there's turbines that are also being developed in Lake Erie, like I mentioned, so projects over there might come out first, and that might be something that Ohio learns about before Michigan has to learn about it.
Hi, very nice presentation. Thank you for participating. Is your research is ongoing?
Yes.
Okay, rather than me asking you numerous questions, I will be merciful. I do have quite a few suggestions where you may wish to add information to your report that I jotted down here. One thing that I would mention, though, is you mentioned the University of Maine.
Yes.
Did you run across the name Matt Simmons? That's okay.
No.
Matt Simmons has passed away, but he was
Sorry.
one of the biggest promoters of talking about peak oil, and he actually got tired of that. He was on television all the time talking about peak oil, and there's a limit to how much oil there is out there, and there's a lot of controversy about whether peak oil even exists. We'll leave that out there for somebody else to debate. But he was one of the driving forces at the University of Maine. He changed gears from an oil consultant to move into promoting offshore wind. You may want to look, plus he had a lot of money, so I assume that there was a big result, or at least inertia from what he was doing, because he was very interested in offshore wind. And I wouldn't be surprised if the University of Maine research was a function of what he was doing.
That sounds about right, because the University of Maine does have a large offshore wind department, which is how they're able to deploy a prototype off the coast of Maine, and they're working on a project. They got a DOE funding, I don't remember how much, millions of dollars, to actually develop a huge wind farm out there.
Now, since income inequality is a big issue these days, did you look at rich people not wanting to look at windmills? I just thought I'd throw that out there.
That might be too politically correct to do in a GIS project, but I look at population instead, and if I go back to looking at, let's find a bigger map. So over here, I forgot to mention the population. There was more people populated in the Muskin and Ottawa counties, and this was the region that the Scandia project was supposed to be outside of. But this population is like for the entire county, so I don't know if the people are living on the coast or if they're living more east, but population might correlate with income, might not, but it's less politically correct. Less politically incorrect. Sorry.